So if you guys don't recognize me, you probably don't. My name is Peatt. I work at Mobify as a designer. We're a company in Vancouver that makes mobile e-commerce experiences, so websites and apps. And I think through our builds, we've been finding that there's a performance problem that's been coming up more and more often, which is that as we fix or make our sites faster, we still run into situations where our sites still feel slow or apps still feel really slow. So one of the things that this comes down to is the fact that I think designers probably don't really care too much about performance. How many people in the audience right now or would consider themselves designers or developers, or identify more with the engineer side of things? More engineers than designers? Okay, yeah. So you guys can probably all agree with me here is that designers, for the most part, are kind of the culprits when it comes to performance issues. And we're kind of bad guys because we don't really think about performance at all. We might make some token optimizations here and there, do things like crush images, maybe concatenate our CSS files, maybe, if we're lucky. But for the most part, what we do is we just leave it to the engineers. We figure you guys know how to handle it best, and then you'll just fix whatever problems we create. And this is kind of a crazy thing, because performance is actually a really big design issue. We should think about it as a core design feature. It impacts the user directly. And the reason we shouldn't just leave it to engineers is because engineers kind of think more about systems. You guys care more about how everything works together. Not that you don't care about the user, but the user is kind of our purview, or we like to think it is. So we really should be thinking about performance as if it's a feature, and that's because it's directly user-facing. It directly impacts the user, and as designers, because we fight for the user, we really should be spending as much time on performance as we spend on anything else. So we should think about performance as if it's a user story. We should plan it as much as we plan any other feature that we design, and we should really think about it. But I think we have also a little bit of a problem in our industry, which is that we don't really have a good way to think about users, which is that we kind of look at analytics and logs, and we think about them as if they are our users. We look at things like load times or asset requests, and if we make those smaller or we make them fewer, we think about that as if it's an improvement. So when we just pat ourselves in the back and we figure our job is done. And the problem with this is that our users don't really care about that at all. Those numbers definitely impact them, but it doesn't really matter if those numbers go down if our users never notice that they go down. So what we need to do instead is focus on improvements that are really obvious to our users, that are really clear that things feel faster. And it doesn't actually matter, it turns out, if things actually are faster within our apps, as long as they feel that way. So that's sort of the idea of perceived performance. And it's not that weird. Our users really aren't perfect machines, and they're not anything like us. They're not using the resource panel or anything like that. They're not criticizing us over our optimizations on performance. All they do is use our app and then make snap judgments about how fast it feels to them. So I think one of the things that we have to keep in mind here is that technical optimizations for performance are still really, really important. Making those magic numbers go down is a top priority for us. But it shouldn't be the highest priority. What we should be focusing on is making things feel as if they're as fast as possible. So as designers and developers, what can we do about that? Well, I think we can think about this the same way we think about any other problem, which is just kind of identify some core problems with perceived performance and then figure them out from there. So I thought about three things with performance, which is that it's relative, it's experiential, and it's ongoing. So when I say performance is relative, I want you guys to think back to maybe the year 2007 when the first iPhone came out. All of our computers had these great dual-core processors in them, and everything felt really fast. And if you think about it back then, the things before that actually felt really fast too. So like your Motorola Razr probably felt really fast the first time you had it. And if we think about it, that kind of idea really makes sense. Things get faster as we move along, and that makes the things that were slower beforehand feel a lot slower in comparison. That makes sense. So as we make our apps faster, older apps just feel slower. So that sort of relative performance makes sense. But there's actually a little bit more to it than that, which is that there's probably a bit of a fun phenomenon that you've encountered before, which is that the more we use the same things, the more we get used to them. So you can kind of think about this as if you're driving down a highway or something like that. So I'm Canadian, so forgive me if I get the conversions wrong here, but pretend you're going like 65 miles an hour and you're going somewhere, that's the normal speed limit, right? 65 miles an hour and you're going somewhere for like 4 hours, so you're traveling at that speed for a long time. As soon as you get into the city, you switch to 30 miles an hour, it starts to feel really slow. It kind of feels like you're crawling. Whereas if you're kind of just making that 30-mile-an-hour trip in the city, you feel like you're moving at an okay pace. But for some reason, when we travel at a really fast speed for a really long time, as soon as we go slower, it starts to feel really slow. So this kind of equates with our apps as well, which is that if we make our apps really fast, but we still have little slow bits every so often, those slow bits feel way slower than they ever did before. So this is kind of what I mean when I say performance is relative. And there's a big problem here, which is that we're not really alone. So we're competing with apps that are faster by default, which are the native apps. They're just faster out the gate. So this is kind of a big impact of relative performance, which is that we have to compete with these people that are faster than us kind of by default. And we don't get a break just because we're building with web technologies, because our users are not comparing us that way. We're competing with everything similar that they've ever used, and being web-based is really no excuse. So at this point, you might be feeling a little bit depressed, because relative performance kind of turns apps into an arms race where we're constantly fighting against native developers. And we have to directly compete with native apps on their own territory, which is kind of dangerous. But I don't want you guys to worry about this, because A, we've got a bit of an advantage. We're thinking about it right now. So compared to other hybrid or web developers out there, we're ahead of the game already. Native apps are going to get faster and faster, and it's going to be a bit of a battle for us to keep up with them. And we're going to have to work really hard to make sure that they feel, or our apps feel, as good as theirs do. But if we think about it, this is actually really awesome. It doesn't suck at all. It's great. It's great for us because it's going to push us really hard, but it's also great because it's good for the user. If we make sure that we're pushing really hard to make our apps fast, our users are going to benefit greatly from it. So the other really cool thing about this is that once everything is done technically for performance, so once we make our apps as fast as they possibly can technically, performance actually becomes entirely a design and front-end development problem, which is pretty cool. So all we have at that point is methods that make our apps feel the fastest instead of actually just being the fastest. And as designers and developers, we get to be the owners of performance, which is pretty great. Finally, there's another really cool thing here, which is that there's such a thing as essentially instant. So that means that there's a limit on what humans can actually perceive as instantaneous. And if as long as we perform within those limits, we'll easily be the fastest and stay that way. So what that means is that we can actually fix the relativity problem. Assuming that perception doesn't change, and we have reason to believe that it doesn't. Jacob Nielsen did a study in 1993 based on some research that IBM did in the 60s or 70s, I think. Then they outlined 3 major time limits to keep in mind when you're thinking about performance. And actually, if we can hit those time frames, performance becomes an absolute issue, not a relative issue at all. So let's look at those time frames. The first is 100 milliseconds. This is a time limit where anything sort of within 0 to 100 milliseconds feels essentially instant to the user. Lower is obviously going to be better, so if you can do 50 over 100, that's great. But if you can perform in that 0 to 100 millisecond range, that interaction is going to feel instant. The next one is 1 second. So with a 1 second wait, the user still feels as if they're in control, but they still know that they're waiting. So they're waiting, but they feel as if they're waiting for something. And often a user will feel like a 1 second wait is worth it. The next time frame that they bring up is 10 seconds. So 10 seconds is a really bad number. That's why I made it red. At this point, the user's probably lost their train of thought. They may have switched tasks. They probably even switched tabs away from your app, using another app now, and they're never coming back to yours. You should never, ever take 10 seconds to do anything in your app. Or you should never feel, at least, like you're taking 10 seconds to do anything. So we know we can fix the relativity problem because these numbers haven't changed. They were true 20 years ago when Jacob Nielsen did a study, and they were true 20 years before that when IBM did theirs. They're still true today. So that teaches us that it's a beatable problem. If we can make everything feel like it reacts in under 100 milliseconds, we'll be the fastest we could ever possibly be because we'll be instant. So if we use that as our target, we can design for that. And we have to remember that it's more about the experience than it is about the actual numbers. So we just need to feel like we're under 100 milliseconds. This is Alan Pike, and he wrote one of my favorite articles on perceived performance, and I think he wrote it in 2011, but it's still like such a mainstay on the subject that it's great. In it, he talks about a timeline of perception, and he wrote it about native app development, and that actually makes it perfect for us as web app developers because that's what we're targeting. We're trying to get to be as fast as them. So in it, he kind of outlines a few stops on that timeline of perception. The first one is the idea of animations moving at 60 frames per second. That equals 16 milliseconds per frame. This is the target that iOS and Android use, so this is what we should use as well. And what he also states is that it's actually better to animate, to not animate at all than it is to animate chunkily. So if you can only animate at 10 to 20 frames per second, you shouldn't put that animation in your app because it's just going to feel slower to the user than just popping it in instead. So try to animate at 60 frames per second, and if you can't, maybe don't animate at all. The next stop on the timeline is under 100 milliseconds. So you can see this is kind of lining up with Jacob Nielsen's research. So what Alan says is that every action should respond or look like it responds in under 100 milliseconds. And really, there's no reason for us to take longer, because if we're under that number, then we're basically untouchable. People will be able to be as fast as us, but they'll never be able to be faster. And that means that our app will never feel slow, which is pretty cool. The next stop on the timeline is 1 second, and this is under 1 second. So if for some reason you can't be under 100 milliseconds, you pretty much have to be under 1 second. And in that sort of time frame, so over 100 milliseconds and under a second, what we should start to do is give users an indication that something's happening at that point. If you remember, what we want to do is engage with the fact that the user knows that they're waiting. We want to give them a sensation of how long that wait's going to be. So we could use something like an animation, like a progress bar or a spinner. Although, as we'll see a little bit later on, maybe spinners aren't the best choice. But we'll talk about that a little bit more later. So the final stop on Alan's timeline, and you'll notice this is actually different than Jacob's, because he doesn't give us much leeway here, is over 1 second. Alan says that nothing should ever take longer than a second, or nothing should feel like it ever takes longer than a second in our app. If we do this, our users are going to hate us. So we really want to avoid doing this. Our apps will just feel slow if we ever take longer than a second. So we can actually use these numbers when we're building our apps as design goals. If we get all of our interactions under 100 milliseconds, then we know that relativity is not a problem, and people will be able to be as fast as us, but never faster. So then now that we know what our targets are, what are some ways that we can actually reach those targets? Because I think those are hard numbers to hit, probably. So we'll outline some techniques here about what we can do to actually kind of get under those target numbers. And the nice thing about it is that perceived performance means that performance is entirely experiential. So users don't care about the numbers, they just care about the sensation of speed. And this is sort of the phenomenon that I call the wind in your hair. So you guys probably know this feeling, which is that if you've ever rolled your car window down or driven with a convertible or something like that, the sensation of kind of that wind passing through your hair over your face is so much more important than the actual speed that you're driving at. It's sort of that sensation of speed. And as humans, we operate through experience. So it's really important for us to feel fast more than it is for us to be fast. So I'm going to try a bit of an example, and I apologize to the sound guys because, we'll see if this works. It might not actually play. If it doesn't, it'll be fine. We'll see. Getting anything? No? Okay. Pretend there was sound there. So basically what I was playing there were two car sounds. I won't go into too much detail, but essentially I wanted you guys to close your eyes and just picture what the car sounded like, and pick which one felt faster to you. The idea there was just that we have a big, I think, emotional experience tied to speed, and we have all of these emotional factors that we kind of draw on when we have that sensation of speed. So for the car, it was relevant because there was a problem the car industry actually faced recently, which is that as they got better and better at building cars, they found that they were blocking more and more road noise and more engine noise in the cabin. And what that meant was that people driving the cars actually felt like they were less powerful because they didn't have the sensation of speed that the car engine noise was giving them, or the sensation of power. And at least for one car company, there was one solution that they came up with. So the BMW M5 can actually pump live engine noise through the car stereo. And they found that this makes their cars feel faster. Users responded really well to this. They felt more powerful. They felt like they were moving at a better, not necessarily faster, but they felt like the car had more power behind it. And the same principle definitely holds true for our apps. If we're fast, but we feel slow, so like blocking engine noise made that car feel slow, if our apps make our users feel like they're waiting a long time, we're basically screwed because it doesn't matter how fast we are if they think we're slow. So let's say we follow those design goals that we outlined. Maybe we have a lot of interactions happening under 100 milliseconds. Maybe we have a few calls to download some data here and there that take a little bit longer, maybe still under a second, but over 100 milliseconds. And we know that those calls are great because they speed things up overall. We have a bit of a tendency to do something crazy while we're making those calls, which is that sorry. Okay. Yeah, we put spinners up, right? While our users are waiting for those things to happen, we actually make them sort of laser focus onto that wait. And the problem with spinners is that they actually make time go on forever because there's no indication of when things are ever going to finish with the spinner. You just know that you're waiting, and that's all you're thinking about. So you see that spinner and you're just like, oh, okay, well, I guess I'm waiting. And time actually stretches on while you think you're waiting. So Luke Wroblewski wrote an article about this, about his app Polar. This is a really great article. Sorry, the link is really small. We'll put it up afterwards. But in it, he outlines how spinners are bad and how he found that spinners actually caused a big perceived performance impact in his app Polar. So what they did was they built a pull to refresh function in their app, which loaded in new polls. And they put this up, and they immediately got feedback saying that loading polls felt slow. Because when you pulled down to refresh, it would just pop a little spinner for maybe like a quarter of a second as those polls loaded in. And they thought this was really weird because they actually knew that loading polls was a lot faster than it had ever been before. So they didn't really understand why users felt like it was slower. So their fix was just to upload a new version of the app with a different animation. So all they did was have the polls animate back in instead of having a spinner there. And users instantly responded that they felt like it was way faster, that polls were loading really, really quick. They loaded in exactly the same amount of time. They just took the spinner out. So right now, we kind of make our app waits like lines at the passport office, where our users kind of just take a number, and then they wait for their number to be called. What we should be trying to do is make our apps wait like lines at Disneyland, where you're actually excited to be going through that wait. Maybe you're distracted, or you've been misdirected in some way that you don't ever actually feel like you're waiting. So one of my favorite rides at Disneyland is Indiana Jones, and it's not necessarily because of the ride, it's because I actually like waiting in line there because of the experience of the line. There's something to be said about misdirecting the user through a wait that makes the experience so much better. You don't really understand or know if you're waiting or if you're just actually having fun in the meantime. So there's a few ways that we can avoid the spinner, because I think this is something we all fall prey to. It's just a really easy way to show users that they're waiting. And there's a bunch of great tricks for a different range of waits that we can use. So the first one is one that the Google app uses, and they have a load time that's about 200 milliseconds for the results. So this is kind of a hard animation to watch because it happens pretty quickly. But if you see when I tapped the word performance, it's actually loading in those results, and it takes about 200 milliseconds. And they didn't want just a white screen while that was loading in, so they have this animation where the results come up from the bottom. And that short animation is enough to make that 200 millisecond wait feel like it's instant, because you kind of see that animation load up, and then the results kind of pop in alongside them. So that makes short waits feel even shorter. The next one that's a really great trick to use is one that Polar uses, and you've probably seen this on Facebook very recently, which is their website uses it, I think, to great advantage now, which is page skeletons. And the idea here is to gradually load content into predefined blocks, which creates this sensation of instant loading, and then you just load your data in on top when you get it. I think Polar does a really great job of this, actually, because they kind of have multiple stages of skeleton content, which you'll see is if they have like when they load in the avatars, what they have is like a gray block, and then they have like an illustrated avatar, and then the actual avatar loads in on top of that. So you kind of have multiple steps of skeleton content to make it feel like something's happening, even if they haven't got that data yet, which is pretty great. So this is a really good technique for when you're approaching closer to 1 second. You can kind of hide that wait time behind some other tricks. My favorite one, however, is this method. And I'm actually not positive if Instagram is still using this, but they were using it about a year ago, where they excuse the picture, where they upload the photo actually while you're making all these decisions. So instead of uploading it at the end when you've already punched in all your data and then waiting for that photo to go up, they've started uploading it at this point. It's going to the servers, it's going to be there, so that when I finally hit post here, it's just going to be there. People can see it already. So the idea here is that you should perform actions optimistically for your users. If you can hide load times behind things and just assume that they're going to work at the end, this is a really great way to hide those kind of longer load times. And if it errors, you can still just tell them afterwards, which is exactly when you were going to tell them in the first place anyways. So this is a really good trick for when you have to take longer than a second for hiding it and making it feel instant instead. So I think we fall into a trap as developers for users, which is that we feel like we have to be really honest with our users. But there's nothing saying that we can't misdirect from what's actually going on when we're building our apps. And I think we want to think about this as if it's like a bag of magic tricks, essentially. We want them to be looking over here while we're doing something crazy over here instead. We want to use all the tricks that we have in our kind of bag to make them feel like things are happening a lot quicker than they actually are. Because we're never going to be able to be that fast, but we can at least make them feel like they're fast. So the final thing to think about is that performance is an ongoing issue. So we know why we should care, and we know some tricks about how we can achieve the goals that we outlined. But the last problem that we have to think about is the fact that performance never really stops. So the first page load in an app is just the beginning. Every page load after that is important. Every action on the page, every animation on the page, every single thing you do is important for the user to feel as if it's performant. So every time we add a feature or change a feature, we need to make sure that we're keeping up with it and considering the impact that it has on our sensation of performance. If it doesn't perform in under 100 milliseconds, can we make it? If we can't, can we make sure we're distracting enough so that it feel like it is? And if we're even doing that, could we do a better job of it later on? We need to consider everything we're doing and making sure that it feels as performant as possible. So I think really the biggest challenge here is make sure that we care about perceived performance, and we make it an issue that we actually think a lot about. So you guys have already stepped up and said, yeah, we care because we came and listened to me chatter for 20 minutes, and you're going to spend some great time with Zach and Justin learning some techniques. But you guys also need to convince your team to care, because it's not enough for us to just kind of do this on our own. This is a really big endeavor. So the more you can convince your team to care, the more successful you'll be overall. And there's a few ways that we can convince our teams to care more about this. One of the ways that I like to do is just to implement some proof of concepts. The nice thing about perceived performance is that you can show really quick examples of these load times without actually having to put them into your apps right away. So this is actually what we're going to do today, is we're going to build some proof of concept for perceived performance gains. And you can actually show those to your teammates to show them where there are some places in your apps where you can make some gains. The next thing I want you to make sure that you do is that you don't just use the ones that we show you today, because perceived performance is very much a creative exercise, and it's going to be different for every single app that you make. So you want to sort of think about the tricks that we're showing you and think about ways that you can apply those directly to your work. Learn our tricks and then use those to kind of create new ones and expand upon them. So you really do have to believe, and I think we have this problem where we like to create whiz-bang features and we design our apps more for other app developers to look at than we do design them for the users themselves. We want to show off our cool new features or the amazing things that we can do. And when we do this, we kind of end up making our stuff worse. So instead, what we should do is be good to the user. Instead of focusing on being fancy, focus on making things feel fast. And sometimes you can kind of make those the same thing. You could use a cool animation to hide the fact that you're slow. And if we do this, our users are going to thank us, our clients are probably going to thank us, and everything on our page will actually make the user feel like it's helping them do something instead of just waiting for an animation to finish. So technical optimization is still important, but you guys really want to have to think about how everything feels to the user when they do it. So next up, we're going to go into Justin, who's going to go over some tips on how to make your animations on your app feel really fast and maybe perform at that 60 frames per second number that we talked about. Thanks, guys.
Cool, thanks, Kyle. So, so Kyle, basically, one of the things, so first of all, I'm Justin. I'm an engineer at Mobify. One of the things Kyle talked about is that 16 milliseconds that we want to aim for. So I just want to give you guys some tools. One tool actually called Velocity.js to achieve that 60 frame a second animation. So what's the issue? So, well, first of all, like if you're trying to animate in JavaScript and you're using jQuery, well, it's pretty awful. It's slow, it stutters. There's a whole bunch of problems with it. Yeah, it's slow. So we do things in CSS, right? Except that some things are really hard to animate. It's really a mess to write complex animations. It's not easy. Like, I leave this to the designers normally because they're better at that stuff, but yeah, it's hard. And it's also really hard to synchronize JavaScript with animations, right? So wait a minute, why is jQuery slow anyways? One of the reasons is because of layout thrashing. So jQuery is designed to do a lot of things. And because of that, it's not super optimized for animations. And what layout thrashing is it's essentially if you read a value from the DOM and then you write a value, when you write that value, it actually invalidates the layout. What that means is next time you read it, your browser needs to recompute the entire layout. And that's really slow. And because jQuery is not optimized for animations, it ends up doing this type of thing a lot. Another reason is garbage collection. jQuery has a lot of objects it's creating in the background, and that ends up creating stutter. One more reason is that jQuery actually uses set interval for animations, which is pretty bad. We have some better APIs for that today, like request animation frame. So I want to introduce you guys to Velocity.js. How many people here have heard of Velocity? Right on. How many people here have used Velocity? All right, perfect. So one thing about Velocity is that it's really fast. It's as fast as CSS animations or faster. And it's pure 100% JavaScript. You don't even need jQuery for this stuff. It's got full browser support all the way back to, I think, IE 8, maybe, something like that. Anyways, it's actively developed. It's really well documented, and it's actually sponsored by Stripe as well, which is really cool. So how is it so fast? It avoids layout thrashing because it's built for animations. It caches DOM properties so that it doesn't need to go and read the DOM between every frame. It uses request animation frame instead of set timeout, and it also falls back to set timeout if request animation frame is not supported. It avoids garbage collection because it's built to be really performant, and it tries not to allocate too many objects. So this is really cool. How do you use it? Well, one of the cool things too is that it's completely compatible with jQuery.animate. So you can actually, if you drop in the velocity script and you're using jQuery, you can replace .animate with .velocity. So this is an example of how do you animate some properties. So now we're going to jump in straight into workshop exercise. So one of the things that I learned recently, actually, I leave design to designers normally, but I realized that, or I learned that accordions are really hard to implement using straight CSS. Because you don't know how big your content height's going to be, and yeah, so basically you can't animate height 0 to height auto, which I didn't know before. So an accordion's a great example for something like velocity. So if you guys just want to open this URL, and we'll just jump into that. How many people here are actually going to do this exercise? All right, a couple, a few. It's going to be fun, I promise. You guys should open it. There we go. I convinced a few people. Kyle to the rescue. Cool, we just got to put this up on screen. All right, sweet. So who here is at this code pen? Few of you, one. All right, you guys got the link. Should I put that up on screen again? We'll drop that in. So I'm just going to introduce the problem real quick. So this is an accordion implemented using CSS. What you guys want to look at is the JavaScript tab here on the side. There's a small description that explains the problem we're trying to solve. And there's velocities already included in this CodePen, which is really cool. Who knows about CodePen? All right, so CodePen is basically like a small staging environment to basically create snippets. So yeah, in the JavaScript section, velocity is already included on this page. If you guys just want to follow the instructions in here, and it's going to teach you how to take your CSS accordion and implement it using velocity. So probably we'll just walk around, and if you guys have any questions or comments or anything like that, we'll try to help out. Cool. Everything good?
Is it like 4?
Oh, yeah. All right, cool.
Yeah, it was taking me just to like the main code page.
Oh, really?
So I just searched for accordion.
Okay. Yeah. Yeah, so actually, if you guys get to our main CodePen page, you can just click Perceive Performance Workshop, and then it is the CSS accordion link. And you guys might want to keep this open too, because we'll use this for other exercises as well. So, small question, what is CodePen? Yeah, CodePen's basically, I guess, a small online IDE for sharing and creating snippets. Yeah, it's pretty useful as like a training tool, I guess, if you don't, or you want to show off some technique or something. It's like a fancy paste bin for the web. All right, so how many people managed to convert this to velocity? All right, so a little tricky. I'm just going to show the solution real quick so Zach can move into his exercises. Just going to switch to that. So here's an accordion implemented using velocity. It pretty much seems the same way. It does the same thing, except it supports infinite content, which is kind of cool. This is what my solution looks like. So we're using jQuery to bind on the click handler for the item. And then on the item, we don't actually want to we don't want to slide out the entire item. We only want to slide out the content area. So we just grab that content area. If it's already visible, we just slide it up, which hides it. I just set a duration of 200 milliseconds here. And otherwise, if it's not visible, we slide it down. So that's what we have for that. So yeah, thanks for going through that. One thing I want to say is we built some open source modules for this. They're in the Google Doc that Kyle put the link up to at the start. Maybe we'll put that back up at the end. They use velocity. They're really well made. And there's a gallery, but I'm just going to skip it for now. So the main takeaway from this is that you can build performant animations in JavaScript. If you have some really complex animations, go ahead and do them in JavaScript. Use velocity. Yeah, it's a fantastic tool. It's pretty recent too. So thanks a lot. We're going to move into Zach.
Hey guys. So I know it's end of the day. I myself am a little bit tired. So I thought we thought it would be good to move on to I'm just going to put that down. Move on to something that's outside of the laptop. So I passed around some paper and pens. And actually, sorry, don't close your laptops yet, because we need the code pen still. Yeah. I wanted everyone to group up, though. So if you've been sitting by yourself or in a group of 3, that's fine. But I'd like to have everyone in groups. So say hello to your neighbor, talk about what you had for lunch, or where you're going to go for a beer next, whatever you'd like. Introduce. Okay, so I'll talk about the few different things, and I'll talk about what we're going to do for the next 15, 20 minutes. What I've done is I've made a few code pens in the collection that we showed earlier that outline a few common situations where designing for perceived performance can bring some real benefit to the experience. So the first one is a basic, I called it a basic content load. I shouldn't use this as an excuse, but I don't write a lot of JavaScript, so you'll have to excuse my JavaScripts if they offend you. But basically the way this is written, so you have a constant amount of time you have to wait until new content is AJAXed in. It's written into the JavaScript that you have to wait 500 milliseconds. So when I press this load content button, the user waits half a millisecond, and then we get new bacon ipsum. This is the only thing that happens right now. It's not the best experience. I got some hover states on the button that make it feel responsive, but that's not the greatest. This is one of those situations Kyle was talking about where it's less than a second, but we can do things to make this feel almost instant. So this is an example where you might not be able to get the content to load faster, but you can make it feel faster. The next example is this photo uploader with these really fancy chickens. And this is another situation where you have a fixed amount of time. You got three seconds until this photo is up, though that's the reality of the code in this imaginary situation that you're looking at. When the user presses upload button, 3 seconds go, and then the image disappears. So it's not the best experience for the user. There's a lot of things wrong with what's going on here. And this is one of the situations I thought it might be good to think about how we can make this better. Honestly, thinking about how to solve a problem is half the battle. And then there's this one, randomly timed load event. So this is, in my experience at Mobify building a hybrid app, you have to plan for various lengths of time. You don't always know when the content's going to come to you. And this is one of the times where we'll have this in this fake scenario. So you put in your search query, and you wait a random amount of time until your bacon ipsum results appear. A random time is built into the JavaScript right down here. So it's anywhere between 0.5 seconds and 4 seconds. So you'll want to like get into the user's mind and like brainstorm like how can we make this better. I went over earlier all the different cool things that CodePen does. Like you can bring in different resources. If you not a fan of jQuery, you can change that. You can write CoffeeScript if you want. You can bring in a different CSS library. You can write in a templating language. There's a lot of different tools available to you. But like the most important one when you're starting is pen and paper for me. And I think it'll be good, especially in group exercises, if we're talking to each other, brainstorming ideas, sketching them out, and then we can present our solutions in 15, 20 minutes. If you have like a killer idea that's not going to take much time to implement, feel free to dive into your CodePen and make whatever you want happen. I'll present a couple of the like basic solutions that I made at the end, but this is more an exercise about starting to think about perceived performance and figuring out ways that we can make our app feel faster than it actually is. Okay, so yeah, feel free to start. Does anyone need the link up again for the collection? We're all good? Yeah, the collection, and then it's these three, like photo uploader, basic content load, and then the random load time event. Okay, so everyone good? Okay, guys. So I think I thought it would be fun if we maybe talked about our different solutions. Was there anyone that wanted to share a particular one they did? Kyle, I need to get on your computer. Yeah, Steve. I have to speak kind of loud.
Cool. Can you put up that randomly timed load?
Right. Yeah. Everyone always picks that one.
So the one you don't have a solution for.
Yeah. Is it salmon or tomato on the background there?
Nice color. So we were talking and we figured like one of the main problems right now is when you click submit, the search results from the previous search they just sit there. They don't leave until the new results are ready.
Right.
So to the user it looks like nothing happened when you click submit.
Yeah.
So the biggest problem is you want to do something to make it click so they don't worry and start clicking submit multiple times. Our suggestion was first off, right when submit gets clicked, you clear the results from before. And then our second suggestion is when you click submit, maybe besides search results, you have a colon and actually puts the search term. So say you're searching hello, it would go search results colon hello. And then that way the user sees something that's changed right away, other than just the other results being moved.
Right.
And then the new results will come in.
Yeah. Those are both great suggestions. You two up front here, did you want to go over your idea?
I don't have that.
I enjoyed your 4-second idea. I thought that might be worth sharing.
So my idea was, if you literally take the problem at face value, then the problem is that it's a random event, so it's unpredictable to the user. So that's the thing that's jarring. Sometimes it's fast, sometimes it's slow. So I just thought one approach that you could take would be always make it take the maximum time, and then you can do something predictable with UI, like you can have maybe a static filler bar that every time it's going to take the same amount of time to fill.
Yeah. An honest loading bar.
Yeah.
I like that.
Sort of honest, like backwards honest.
Yeah.
There's a funny thing about loading bars, which is users kind of feel like they win if something happens before that loading bar completes. So you can even show that loading bar and not have it complete the whole way and just display the results as soon as they show up.
That probably would have been something we could have talked about longer too. Is fake loading bars are not necessarily a bad thing. One of the great points Kyle brought up was how lying to the user is not necessarily bad. A lot of times people want to be lied to about those sort of things. Any other solutions people want to talk about? You guys in the back middle there? We good?
Well, we're thinking for the upload one.
The fancy chickens?
Yeah, sure. You start kind of like, I think there's a line kind of like folding it, folding the image in, and like
Right.
And then like Vail, maybe like start up more videos.
Yeah. Cool. We are getting pretty short on time here, so we have a collection of. I have a couple solutions that I've put up on our CodePen page. I'll just show you one real quick, just for the sake of time. This is something that you could probably take home with you as well. There's this thing called Google's material response in their new design language, where you make a click and it ripples out from where you've touched. It's something that's implementable on a mobile device and can help the user understand that they just clicked something and that their response was felt. Helps the interface feel responsive, and it's distracting. So when I'm looking at that fancy ripple, I'm not necessarily focused on the time that I'm waiting. Might be a good thing that you can bring home with you and possibly implement on your websites today. I'll bring up our information right here, and I'll just do a quick little wrap up. We don't really have I'll just put Kyle's face up there. So yeah, the three of us, we work at Mobify. We do hybrid apps and mobile websites. This was our presentation on perceived performance. Thanks.